Hello there, welcome to the official Philosophy of Cognitive Science podcast. My name is Alex.
And my name is Magnus.
Today we're going to be covering the theories of two notable philosophers of science that worked during the 20th century. But first, we need a recap about the last episode to get us back on track.
Okay, so let me do the recap.
Okay, go on.
If my memory isn't failing me, I can recall that we talked about logical positivism and Karl Popper. Logical positivists were influenced by the empiricist tradition and proposed verification as the demarcation criterion. Verification means that we must find evidence to prove a statement is true. They also supported the received view of science, whereby we observe phenomena, collect individual observations, and establish a universal statement using induction. However, this view has two major flaws, the problem of induction and the problem of verification.
Yes, you have very good memory, I must say.
Well, always up to the day of the exam, then boom, I can't remember anything.
The classic exam memory loss syndrome. I mean, it's nothing out of the ordinary.
We also talked about Karl Popper, another philosopher of science, who proposed an alternative view. He proposed falsification as a demarcation criterion, because we can contradict a universal statement with a single individual observation. This means that something considered scientific must be able to be falsified, namely proven false.
Popper's theory is typically called a prescriptive theory because it explains how science should be done.
So, what philosophers of science are we going to look into today?
We'll cover two philosophers of science in this episode which acknowledged that falsification is a valid demarcation criterion of science, but they put forth their own theories, descriptive theories, to explain how science actually works in the real world.
So, it's like Popper invited them to a party, but they showed up with their own theories and said, nah, we'll do it our way.
Yeah, exactly. Kuhn and Lakatos didn't quite follow the falsification-only party line. They each had their unique approach to understanding how science progresses.
Okay, but tell me, Alex, who are Kuhn and Lakatos?
Well, the first one we're going to cover is Kuhn, as you just said. Thomas Kuhn was a famous American philosopher of science. He wrote The Structure of Scientific Revolutions, a famous book, in 1962, and he's very famous for having popularized the notion of scientific paradigms and revolutions.
Okay, what did he propose in this book?
Well, Thomas Kuhn proposed that science essentially consists of paradigms. He also proposed that the four stages of science. The first one is pre-science, where there's an accumulation of observations, effects to be explained, a lack of agreed upon standard theories, so it's all a bit messy. And due to the lack of agreed upon standard theories, observations will be understood differently by different researchers, so everyone has a different view of the observations. Kuhn argues that the social sciences are in the state of pre-science, for example.
Okay.
Yeah.
So what would pre-science look like?
Well, a clear example of what pre-science would look like is maybe optics before the 17th and 18th centuries, because back then many famous figures like Benjamin Franklin, for example, advanced human knowledge about optics, but before them there was no consensus of how light worked, for example. So essentially there was no accepted foundation in the field, so researchers didn't agree on any interpretations.
Okay, so what comes after pre-science?
Well, after pre-science, Kuhn proposed three more stages, connected in a circular manner. So imagine a hamster going round in a wheel. I mean, that's basically it.
Okay.
So the three stages after pre-science are considered science. They're all part of science. Immediately after pre-science, we have normal science. In this stage, there's a dominant paradigm and most of the science agree on basic aspects. In the established paradigm, there's a set of assumptions which are not really questioned, and they're held as true as long as there's not lots of contradicting evidence. There's also some established ways of collecting and interpreting data, creating models and understanding the field. If some data or observations can't be explained using the assumptions of the paradigm, those observations are largely ignored.
Okay, so one paradigm becomes established with certain assumptions that are not questioned, and a certain way of viewing the field influencing the way science is done. But could you more or less define what a paradigm is?
Yes, of course I can. Paradigms are essentially scientific movements which determine what phenomena are studied, what methods are used, and what good explanations look like.
Okay, what would an example of a paradigm be?
For example, in astronomy, the Ptolemaic model of the universe suggested that the Earth is the center of everything, and the Sun, Moon, and other planets and celestial bodies rotate around the Earth. However, in 1543, with the Copernican revolution, Copernicus put forth his heliocentric model, where the Sun is close to the center of the universe and the planets rotate around the Sun instead. Essentially, according to Kuhn's theory, there was a radical shift called the scientific revolution that took us from the geocentric model to the heliocentric model.
Okay, so that's an example of a paradigm. That's nice to know.
Yeah, right. Kuhn proposed that different paradigms are incommensurable. This means that there's no common measure or no common language. And this term incommensurability is very important in Kuhn's philosophy.
Okay, so it's like trying to compare Roger Federer and Mike Tyson. Tennis and boxing are like completely different games. I mean, they are still games and the goal is to win, but the rules, the goals, how you count the scores, and the strategies are so different that there's no common metric to judge. This is the thing Kuhn is trying to get at. Is that right?
Yeah, you could say so. This makes different paradigms difficult to compare. So, for instance, Ptolemy's system is so different from the Copernican version that they can't be made commensurable. Therefore, they're incommensurable, as I said.
Anyway, I was going to ask you something. Can there be multiple paradigms at the same time?
Yes, there can be multiple paradigms at the same time, but Kuhn mentions that there's always going to be a dominant paradigm. For example, currently in cognitive science, you could say computationalism is the dominant paradigm, but there's also many other paradigms like dynamical systems and maybe ecological psychology as well.
Okay, so it's like there can only be one song occupying the number one space on the trending charts. One gets the most attention for a while the others are still there, but they are sort of in the background.
Yeah, that's the essence of it, yeah.
Okay, so we've talked about pre-science and now normal science, and what comes after this?
After normal science, we have the moment of crisis. This occurs when the established paradigm can't explain many observations. These are called anomalies. It's impossible to ignore these anomalies when they keep appearing, so certain aspects of the paradigm start to be questioned. The confidence in the current paradigm starts to weaken and alternative paradigms emerge slowly.
Okay, so essentially, during normal science, scientists have basic assumptions when engaging in science. However, the paradigm they are working in at some point will fail to explain some observations, leading to anomalies. When there is an accumulation of anomalies, then that's what we call a crisis.
Yes, precisely. But it doesn't end there, Magnus, just you wait. There is one more stage in Kuhn's theory. He proposed that after the moment of crisis, there's a scientific revolution. Essentially, there's low trust in the old paradigm, although some scientists will still hold on to the old paradigm, of course. But there will obviously be division among scientists. This happens all the time in science. But eventually, a new paradigm will replace the old one with new assumptions. Once the scientific revolution has occurred, a period of normal science starts again. Essentially, the cycle of science will continue again and again, following the same order. So first normal science, then crisis, and then a scientific revolution, and then all over again.
Okay, this all sounds very captivating indeed. So let me see if I got it right, Alex. A crisis occurs with many anomalies. There is low confidence in the established paradigm, and other paradigms start to emerge. And then eventually a new paradigm will replace the old paradigm. But this all sounds a bit fluffy as of now. Maybe you could give us an example to illustrate this better.
Yes, I'm going to explain the evolution of cognitive science using Kuhn's theory, if that's okay with you. So, before the 19th century, there was very little research done to study psychological phenomena in laboratories. So many aspects of psychology were studied, like the brain, mind, consciousness, feelings, emotions, among others. But this period would correspond to pre-science because there wasn't any agreed standards in the field.
Okay, yeah, I remember I've studied this. But then Wilhelm Wundt came along, didn't he?
Yes, Wilhelm Wundt established the first psychological lab and theories at the end of the 19th century in Germany, and introspectionism became the established paradigm, focusing on self-reports and also empirical studies of behavior, brain function, reaction time, etc. This would be the normal science stage. However, introspectionism entered a period of crisis in the early 20th century because self-reports were not very reliable and results varied a lot depending on the laboratory they came from. This would be the crisis stage, and eventually, around 1930, there was a scientific revolution where behaviorism replaced introspectionism as a dominant paradigm.
Aha, I can actually remember this. This is when those people said, nope, we don't care what happens inside your head. We're just interested in your behavior.
Yeah, the assumptions of behaviorism then became established, which were that psychology should only investigate external behavior, rejecting internal mental processes. They rejected many terms like mind and consciousness because they were seen as abstract, and researchers focused on stimulus response experiments instead. And after this scientific revolution, behaviorism became normal science.
Okay, I'm very intrigued. So Popper proposed that theory should be put forth and should try to be falsified. As you know, this is a prescriptive theory of science. However, Kuhn tries to describe how science actually works, a descriptive theory. He proposed that science does not move or progress linearly, but rather that it moves in cycles.
Yes, exactly. As I mentioned earlier, Kuhn said that paradigms are incommensurable, which makes them hard to compare. He therefore said that there's an irrational element that comes into play when deciding which paradigm is the best.
So choosing the best paradigm is an irrational choice. It's like choosing which pizza to have. One day you fancy pepperoni, but then the next you're all about pineapple. It's not always rational. Sometimes it's just about which one you're in the mood for.
Exactly. I suggest we move on to the next philosopher of science we're going to talk about in this episode. He's called Imre Lakatos.
Imre, what?
He's a Hungarian. He's called Imre Lakatos.
So what did Lakatos propose?
Well, Lakatos rejected Kuhn's conclusion that scientific change is driven by paradigm shifts that are partly irrational. Instead, Lakatos argued that scientific progress follows a rational methodology through competing research paradigms, where a progressive research program can be distinguished from a degenerative one based on its ability to predict novel facts.
Okay, could we please delve a bit deeper into this notion of a research program that you just mentioned, Alex?
Yeah, so Lakatos said that at the same time there's several research programs. According to Lakatos, a research program is a sequence of scientific theories with central assumptions that form the hard core. The hard core isn't questioned or falsified. They're held as vital to the research program. There's also a protective belt that surrounds the hard core, and this protective belt is formed by peripheral statements which protect the hard core from falsification. They're often changed to keep the hard core intact.
Oh, so it's like the protective belts are keeping the party going, even when the peripheral statements don't always remain intact.
Yes, essentially that's it, yeah.
Okay, so he talked about research programs instead of paradigms. How do these two concepts compare?
Okay, so Kuhn proposed a notion of paradigms, as you know. A paradigm is a broad worldview or scientific framework shared by a community. It includes theories, methods, standards, and exemplars. Kuhn emphasizes the sociological and psychological dimensions of science, so basically how scientists actually behave. Lakatos proposed the notion of research programs. A research program is a logically structured, evolving set of theories centered on a hard core and a protective belt. Lakatos is more concerned with providing a rational reconstruction of science, how it progresses over time with progressive and degenerative research programs. Kuhn's paradigm is a broader concept than the concept research program put forth by Lakatos.
Okay, so let me try to go through the main differences. Kuhn defined paradigms as scientific views that share common theories and methods, among other things. But then Lakatos put forth research programs in a similar vein, but he highlighted the difference between progressive and degenerative research programs, and the hardcore and the protective belt of a program.
Yeah, those are indeed the main differences. But I think now we should talk about progressive and degenerative research programs, like the difference between them. This is a key component of Lakatos' theory.
Okay, that sounds good.
Lakatos proposed that science does not advance by theories being falsified and replaced, as Popper suggested. He also said that science does not advance by a series of periods of normal science, like with a single dominant paradigm, punctuated by revolutions, as Kuhn suggested. Instead, Lakatos proposed that science advances by progressive research programs replacing degenerative ones.
So essentially, science progresses when progressive research programs replace degenerative ones.
Yes, that's it, yeah.
Okay, so in other words, progressive research programs are like a good franchise that keeps getting better, while degenerative ones are like those that should have ended after the first season but just kept going. You know how, like, Star Wars should have ended in '83 with Return of the Jedi,
Yeah, that's quite a good point. After that, Star Wars became degenerative.
right? But, Alex, please give me a science example.
Okay, take Newtonian physics. The scientist Halley used it to explain past comet sightings as the same comet. That made it theoretically progressive. He then predicted it would return later on, and it did, making it empirically progressive too. Okay, Magnus, your turn now. Tell me if Darwin's theory of evolution and natural selection is progressive or degenerative.
Well, I think Darwin's theory is progressive. I mean, he proposed his theory after having embarked on many adventures looking at different flora and fauna. So he explains the past, i.e., why species became extinct through a lack of adaptation to the environment. And he also said that all species have common ancestry. Posterior findings also align perfectly with Darwin's theory. We know that species go through evolution and that they all share common ancestry by looking at fossil records and doing DNA analyses.
Yes, that's correct. According to Lakatos, Darwin's theory is considered progressive, as you just said. But moving to the social sciences, what about Marxism?
Marxism. Well, Marx used dialectical materialism to analyze history as a class struggle between capitalists and the proletariat. Wait, Alex, isn't this a philosophy and science podcast? Why are we talking about Marxism?
Yeah, but as I said, this is like Marxism is like social sciences, economics, sociology. This is also part of science.
Okay. Well, Marx believed that the proletariat would develop class consciousness, overthrow the capitalists, and establish a socialist state, eventually leading to communism with shared ownership and equality. He expected this to happen in industrial societies like the UK, but since it hasn't, Marxists have adapted the theory over time.
Yes, according to Lakatos, Marxism is degenerative. Okay, what about one last one? What about maybe Einstein's theory of relativity?
Okay, Einstein now. Well, Einstein predicted that if you measure the distance between two stars at night and during the day, during an eclipse, the two measurements would be different due to the sun bending in light. So his theory is theoretically progressive. This prediction was corroborated in 1919, so it is also empirically progressive.
Yes, you got it. I think that's enough for now.
Well, dear listeners, then I guess this is the end of the episode.
Yes, but we'd like to remind you that you can listen to the next episode. It's about two more philosophers of science, Gia and Massimi.
And remember, if you don't listen to the next episode, you're going to get insignificant p-values for the rest of your lives. So, see you in the next episode.
See you. Bye.
Bye bye.